What is the objective function? The objective function is given by profit per unit is 30, 20 and 50. 30 for first unit, 20 for second unit and 50 for the third unit. If the number do not exceed the maximum indicated by the market research, formulate this problem as a LP model. The number of working hour available is 20x plus 10y, which is less than or equal to 5. Hello dear students, welcome to this session of Operation Research class. I am Mr. Niranjan, Faculty, Department of Computer Science, Vidhyaashram First Grade College, the Temple of Excellence. In my previous class, I have discussed regarding some definition, very important definitions in linear programming problem, and also how to construct a linear programming problem. Now today, I am going to discuss regarding the formation of a linear programming problem. Now this concept is very important. You may expect one question for the point of examination, either for 7 marks or 8 marks. The formation of a linear programming problem. The formation of linear programming model. Now let us come to the first problem. Now what is the first problem given? A manufacturer produces 3 models. So you will produce model 1, 2 and 3 of a certain product using the raw materials A and B. So a manufacturer produces 3 models, model 1, model 2 and model 3 with the raw materials. What are the raw materials? Mentioned as A and B. The following table gives the data. The following table will give the data. So whatever the requirement, availability and the raw material is put in the form of a data. Using this data, formulate this problem as a linear programming model. Now the question is, just go to the problem. A manufacturer produces 3 models 1, 2 and 3 of a certain product using raw materials A and B. The following data gives the following table will give the data. Formulate this problem as a linear programming problem. Now, what is the given data? The raw material. There are 2 types of raw materials A and B. The requirement per unit. What are the requirements of the model 1, 2 and 3? And the availability, the maximum availability is given 4,000 and 6,000. And the minimum demand, what is the minimum demand? 200, 200 and 150 for the first product, second product and third product respectively. And the profit, what is the profit in the first product, second product and third product is 30, 20 and the 50. This is the given condition. Now, depending upon this condition, let us formulate an LPP. See, whenever the problem the profit is given, means this must be a maximization problem to get the maximum profit with the minimum expenditure, with the least expenditure. That is one of the advantage of this linear programming problem. Getting the maximum profit using least expenditure, least cost. Now let us construct. Now before going to the exact, let us define the decision variable. Let us consider, let me solve this problem. Let us define the decision variable for this unit 1, 2 and 3 as let x, y, z, x, y and z be the decision variable for first, second and third units. First point, let us define the decision variable for the first, second and third unit as x, y and z. So x for first unit and y for second unit and z for third unit. Now then, what is the minimum, what is the profit given? Profit per unit is 30 for the first unit, 20 for the second unit and 50 for the third unit. So therefore, our objective function is let us call it as P is equal to, what is the decision variable we have taken? X for first unit, Y for the second unit and Z for the third unit. Therefore, the objective function is 30x for the first unit plus 20y for the second unit plus 50z for the third unit. Now what is to be determined here? So the profit per unit is nothing but the maximum. So here what we want to do is, the objective function is maximum of P is equal to 30x plus 20y plus 50z. This is the objective function which is to be maximized. This is the very important step. Observe once again. Let us define x, y, z be the decision variable. Let us consider x, y, z as the decision variables for the first, second and third unit. Now what is the objective function? The objective function is given by profit per unit is 30, 20 and 50. 30 for first unit, 20 for second unit and 50 for the third unit. So therefore the objective function is P is equal to 30x plus 20y plus 50z, which is to be maximized. Therefore maximum of P is equal to 30x plus 20y plus 50z. This is the first part. Okay, hope you followed this. Now let us come to the second part. Now for the products A and B, what are the requirements given? The requirements are, first unit contains 2. For the product A, the requirements are 2, 3 and 5. For the product B, the requirements are 4, 2 and 7. And the maximum availability is 4,000 for the product A and 6,000 for the product B. Now therefore this can be put in the form. So straight away easily you can put the decision variables are x, y and z. Straight away you can write for the product A, the equation is 2x plus 3y plus 5z, which is less than or equal to 4,000. The first equation for the product A, right? That is the constraint. Now that is the constraints are for the product A, the constraints are 2x plus 3y plus 5z is less than or equal to 4,000. For the product B, the constraint for the product B is 4x plus 2y plus 7z is less than or equal to 6,000. So I'll put it in the equation form. I'll go to the next page. Subjected to constraints. Subjected to constraints. Subjected to constraints. First one is 2x plus 3y plus 5z for the model A. For model A, that is 2x plus 3y plus 2x plus 3y plus 5z, which is less than or equal to 4,000. This is for the first model. Similarly, for the model B, what is the constraints? 4x plus 2y plus 7z is less than or equal to 6,000. 4x plus 2y, 4x plus 2y plus 7z, which is less than or equal to 4x plus 2y plus 7z, which is less than or equal to 6,000. These are very, very mathematical equations. So, subjected to the constraints, for the model A, the given condition is 2x plus 3y plus 5z is less than or equal to 4,000. And for the model B, 4x plus 2y plus 7z is less than or equal to 6,000. This is 2y. Okay, followed. Hope you followed this. Now, let us come to the minimum demand. So profit is taken and the requirement is also taken, and what is left over is the minimum demand. What is the minimum demand? The minimum demand for the first unit is 200. The minimum demand for the second unit is also 200, and the minimum demand for the third unit is also 150. So the minimum demand, that means x, y, z, these are nothing but the object, that is objective, that is decision variables. The decision variables are x, y and z. Using this relation, you can put in the form of minimum is 200, 200, 150. So therefore, x is greater than or equal to 200, y is also greater than or equal to 200, and z is also greater than or equal to 150. Subject, since these are all positive quantities, therefore the non-negative restriction, subjected to the non-negative restriction, the non-negative restrictions The non-negative restrictions are x is greater than or equal to 0, y is greater than or equal to 0, and z is greater than or equal to 0. This is how we are going to form the linear programming model for the given statement. That's it. Now put all these in the form, in the mathematical, step-by-step mathematical form. That's it. See here, let me explain once again. Let us define, let x, y, z be the decision variable for the first and second and third units. So therefore the objective function is the function which is to be maximized. Here the maximum profit we want to get. Therefore p is equal to 30x plus 20y plus 50z. The objective function is maximum of p is equal to 30x plus 20y plus 50z. Subjected to the constraints. What are the constraints? For the product A, this is 2x plus 3y plus 5z is less than or equal to 4000, and for the product B, 4x plus 2y plus 7z is less than or equal to 6000, less than or equal to 6000, and the minimum demand is, since the minimum demand is given by x is greater than or equal to 200, y is greater than or equal to 200, z is greater than or equal to 150. Subjected to the non-negative restrictions, x is greater than or equal to 0, y is greater than or equal to 0, and z is also greater than or equal to 0. So hence the required LP model is, therefore the required LP model, linear programming model, is max z, maximum of z is equal to, or maximum of p, what we have taken here, maximum of p, or maximum of p, max p is equal to, what is the equation? 30x plus 20y plus 50z, 30x plus 20y plus 50z, subjected to constraints, subjected to constraints. What are the constraints we got? 2x plus 3y plus 5z is less than or equal to 4000. 2x plus 3y plus 4z is less than or equal to 4000. These are the constraints. Subjected to the constraints, what are the constraints? Subjected to the constraints, 2x plus 3y plus 5z is less than or equal to 4000, first equation. And the second equation, 4x plus 2y, 4x plus 2y plus 7z is less than or equal to 6000, and the minimum demand, that is x is greater than or equal to 200, y is greater than or equal to 200, and z is greater than or equal to 150, and the non-negative restrictions, x is greater than or equal to 0, y is greater than or equal to 0, and z is greater than or equal to 0. This is the required LP model problem for the given statement. That's it. Hope you followed this. If you do this much, definitely you will get 7 or 8 marks. Very easy and very important problem. That's it. Come to the next problem. So this is also an important problem. Now, what is the problem given? Just go to the problem. A TV company has to decide on the number of 27-inch, first one is 27-inch and 20 inches, 27 and 20 inches TV sets, 27-inch and 20 inches. Let us consider A as 27-inch TV and B model as 20-inch TV sets. Now, to be produced at one of its factory, market research indicates that at most 40 27 TV sets and at most 10 20 inches TV sets can be sold per month. So according to the market analysis, you can sell 40 27 inches TV and 10 20 inches TV per month. If such is the case, the maximum number of work hours available is 500 hours per month. This is also important. The availability is 500 hours per month. Then a 27-inch TV requires 20 working hours, whereas 20 inches TV requires 10 working hours. So this requires 20 hours, whereas the model B requires 10 hours to manufacture. This is the working hour. Then each 27 TV sold produces a profit of rupees, that is US dollar $120. The profit for product A is 120, and for product B, that is 20 inches TV, produces a profit of rupees $80. A wholesaler agreed to purchase all the TV set produced if the number do not exceed the maximum indicated by the market research. Formulate this problem as a LP model. This is very important. Again, this is maximization. The maximum Z or maximum P, that's it, given to the, just define the decision variables as X and Y for the product A and product B. Now let us define the decision variables as X for the product A and Y for the product B. What is the product A here? Product A is nothing but a 27 inches TV, whereas the product B is nothing but 20 inches TV. Okay, now let us define, let me solve this. Let us define, let X and Y be the decision variables. Let X and Y are the decision variables for the product A and B, that is for the 27-inch TV, another one for the 20 inches TV. Now therefore the objective function is, what is the objective function here is, I'll go to the next page. So that is the decision variables. X represents, X is nothing but the number of 27-inch TV set, whereas Y denotes the number of 20 inches TV set. These are the decision variables. Now let us define, so here X and we are denoting X and Y as the decision variable. Now what is the maximum profit here? So X is the number of TV sets. The number of 27-inch TV sets can be sold is X is less than or equal to 40. And the number of TV sets of 20 inches sold per month, this is per month, is Y is less than or equal to 10. Now let us define the objective function. So the objective function is, let us call it as P. P is equal to, what is the profit we are going to get on selling A, the product A, we are going to get US $120, and selling the product B, you are going to get US $80. So therefore the objective function is P is equal to 120x plus 80y. So this is to be maximized. Therefore maximum of P is equal to 120x plus 80y. Subjected to the constraints, constraints are X is less than or equal to 40 and Y is less than or equal to 10. Okay. Now what is the number of working hours available? Now therefore the number of working hours available is, what is the number of working hours available? 20 hours and 10 hours. So that is 20x plus 10y is less than or equal to, what is the maximum number of hours available per month is 500. This is number of working hours. The number of working hours available is 20x plus 10y, which is less than or equal to 500. So this is the LP model. Now put it in the form of a step by step. That's it. Now listen to me. I'll explain once again. So a TV company has decided to manufacture two types of TVs. First model, first A, consider A as 27 inches TV and B as 20 inches TV sets. So here the TV sets, at most, the market research indicates that at most 40 number of TVs of model A and 10 number of TVs of model B can be sold per month, and The maximum number of working hours available per month is 500 hours. So the number of maximum hour is 500 hours per month. A 27-inch TV requires 20 working hours, whereas model B 20 inches TV requires 10 hours, and by selling you are going to get a profit of US $120 for model A and $80 for model B. If such is the case, so a wholesaler agreed to purchase all the TV sets produced if the number do not exceed the maximum indicated by the market research, then to formulate the LPP. Now very simple problem. Let us define the decision variables as X and Y. X and Y, let the product for the product A 27 inches TV it is X, for the product B 20 inches TV is as Y. The maximum number of hours available for the product A is 20 and product B is 10 hours, and the profit you are going to get for the model A is 120 and model B is 80. This can be put in the form of a mathematical equation. That's it. So let X is the number of 27 inches TV sets, therefore X is less than or equal to 20, that is per month, and Y is equal to number of 20 inches TV sets. So the maximum number of 20 inches TV sets, Y is less than or equal to 10. Now the objective function is the profit 120x plus 80y. Profit means definitely it is a maximization. Therefore the maximum P is equal to 120x plus 80y subjected to the constraints X is less than or equal to 40, Y is less than or equal to 10, and the availability of the time is 20 hours, that is 20x plus 10y is less than or equal to 500 hours subjected to the non-negative restrictions. X is greater than or equal to 0 and Y is greater than or equal to 0. So therefore, hence the required LPP problem is, therefore the LP model, the required LP model is maximum P is equal to 120x plus 80y, 120x plus 80y subjected to the constraints, subjected to the conditions, subjected to the constraints. X is less than or equal to 40, Y is less than or equal to 10, Y is less than or equal to 10, and 20x plus 10y is less than or equal to 500, and the non-negative restrictions, non-negative restrictions, X is greater than or equal to 0 and Y is greater than or equal to 0. This is a required LP model problem for the given statement. That's it. Hope you followed. This is also a very important and simple problem. That's it. Now let us come to the next problem. This is also an important problem for 7 mark. A farmer has to plant 2 kinds of trees. So there are 2 kinds of trees, P and Q. A farmer has to plant 2 kinds of tree, P and Q. So P and Q. In a land of 4,000 square meters. Land he has 4,000 square meters. 4,000 square meters of area. Each tree P requires 25 square meters and one tree requires 25 square meters, and each tree of Q requires 40 square meters of land. This is the land. Then the annual water requirement for each tree P, water, this is land, water requirement, water 30 units, for P it is 30 units of water, and for each tree Q is 15 units, at most 3000 units of water is available. This is 3000, this is land and water. 3000 units of water is available annually. It is also estimated that the ratio of total number of trees Q, the ratio, what is the ratio given? Ratio Q by P q to the number of trees should not be less than 6 by 19. One is 6 by 19. Another one is and should not be more than 17 by 8. 17 by 8. The return per tree from P is expected to be 1.5 times. 1.5 times is 1.5 times as much as the tree Q. Formulate the problem LP model. Again, this is nothing but the maximization. The profit is maximum profit to get the maximum profit. This is the given condition. Now, let us define the decision variables as X and Y. Let X and Y be the decision variables. Now, let us define the decision variables as X and Y. Now, let us consider what is the land used first. 25 square meters for P and 40 square meters for Q, and water resources are 30 units for P and 15 units for Q, and the maximum land available is 4000 square meters and the water resources available is 3000 units. Then the ratio is given that Q by P is, the ratio Q by P is less than 6 by 19 and should not be more than 17 by 8. Less than or equal to, greater than or equal to 17 by 8. Now let us put this in the form of an equation. Now what are the decision variables? X and Y are the decision variables. Now let us come to the page, next page. I'll go to the next page. Now let Z is the maximum profit we want to get. So profit is Z. Therefore, the objective function is P is equal to 1.5x plus Y. The maximum profit from P is 1.5 times more than Q. So therefore, the objective function is max P is equal to 1.5x plus Y. This is the first equation. Followed, X and Y are the decision variables. The function is to be maximized. Therefore, the objective function is maximum of P is equal to 1.5 times X plus Y. Subjected to, what are the conditions given? Subjected to the constraints. Subject to the constraints. What are the constraints given? Let us consider the first. What are the land? So that is land. What is land given? 25 square meters for X and 40 square meters for Y, and maximum available of land is 4000 square meters. So subjected to the constraints. What is the land given? First one is 25x plus 40y. 25x plus 40y is less than or equal to, the maximum availability of land is 4000 square meters. Okay, so subjected to the constraints, 25x plus 40y is less than or equal to 4000. Now the next condition is after land, the water resources. What are the water resources? So water resources are 30 units of water for P and 15 units of water for Q, and the maximum availability is 3000. So 30x plus 15y is less than or equal to 3000. So 30x plus 15y is less than or equal to 3000. If you want, you can write it as this is for the land and this is for the water sources. 30x plus 15y is less than or equal to 3000. Okay. And what is the ratio given? The ratio given, what is the ratio given? Given ratio Q by P. Q by P is nothing but that is Y by X for the first condition. What is the first condition given? Should not be less than 6 by 19. Should not be less than 6 by 19. So should not be less than 6 by 19 means greater than or equal to 6 by 19. And another ratio Y by X, another ratio Y by X is not more than 17 by 8, means not more than 17 less than or equal to 17 by 8. This is the ratio. The ratio Q by P, that is Y by X is greater than or equal to 16 and Y by X is less than or equal to 17 by 8. Okay. Now let us define the non-negative restrictions. Hence the non-negative restrictions, since it is all positive, x is greater than or equal to 0 and y is greater than or equal to 0. Now let us put this entire in the form of a step-by-step mathematical step. So therefore the required LP model, therefore the LP model is maximum P is equal to 1.5x plus y subjected to constraints 25x plus 40y, 25x plus 40y is less than or equal to 4000 and 30x plus 15y, 30x plus 15y is less than or equal to 3000 and the condition y by x is greater than or equal to 6 by 19 and y by x is less than or equal to 17 by 8 and the non-negative restrictions x is greater than or equal to 0 and y is greater than or equal to 0. This is the required LP model for the given statement. Hope you followed this. This is also very important and easy. If you do this much, you will definitely get 7 or 8 marks in your examination. That's it. Okay. Hope you followed this. Now, these are few examples for the formation of a linear programming problem. I'll take few more problems. Before that, let us discuss what are the advantages of this linear programming problem. Now, let us come to the advantages. There are so many advantages. So far, you might have been seen. So, there are so many advantages. This LPP can be used in industries, agriculture, in almost all branches of science and technology we are using it. Actually, this LPP was developed mainly to solve the problems in the war field. Nowadays we are using this in almost all fields of science and engineering. Particularly in the field of industries, we are using the concept of this linear programming problem to get the maximum profit by utilizing the minimum resources and minimum availability of the manpower. We are going to get the maximum profit. For that purpose, we are using the concept of linear programming problems. Now let us list some few advantages of a linear programming problem. So this is also a very important question. You may expect this for 5 or 7 marks questions. Definitely you will get this for 7 marks. This is very, very important. Advantages of a linear programming problem. Some of the real-time applications are in production scheduling and production planning and repair. So maximum in majority cases we are using this for the production as well as for production planning and repair of any units, plant layout, equipment acquisition and the replacement of the equipment as well as the acquisition of the equipments and the logistic management. This is also very important. We are using for the logistic management and even for the fixation. So linear programming has maintained special structure that can be exploited to gain the computational advantages. Some of these advantages of the linear programming problems are, what are the advantages? Utilized to analyze numerous economic, social, military and industrial problems, to solve the problems in the war field and also to solve the problem in economy, economics and social, military and industrial problem. So that is in industries to get the maximum profit with the least available of resources. We are going to use this linear programming problem. Even linear programming problem is most suitable for solving complex problems in an easiest manner. We can solve the complex problems using the decision variables. So helps in simplicity and productive management of a organization, which gives the better outcome, which gives the better result. And To improve the quality of design, to improve the quality of a decision, a better quality can be obtained with the system of making use of linear programming. To improve the quality of decision, the quality of the decision, a better quality can be obtained with a systematic arrangement, systematic making use of linear programming problems. And it also provides a way to unify result from disparate areas of mechanism designs. More flexible than any other system, a wide range of problems can be solved easily with the help of these programming problems. What is the intention is to get the maximum profit, maximum benefit with minimum expenditure, with minimum manpower, with minimum expenditure, we are going to get the maximum output and maximum benefit. So this can also be used in solving the multi-dimensional problems. So these are few advantages of linear programming problems. Okay, so these are very important advantages. So you may expect this for your annual examination. So that's regarding today's session. So in the next session, I am going to take few more problems for construction of linear programming problem. So then you will get an idea. Okay, thank you very much. Thank you. Let's meet in the next session. Thank you.